Hello everybody, Chris here, and in this video I wanted to show you guys many of the differences between a game object and a scriptable object inside of the Unity game engine. So I have the default scene loaded up here, and you can see that we have the scene hierarchy on the left hand side. Inside of that hierarchy we have two game objects, the main camera and the directional light. If we look at the main camera, then you may notice over in the inspector that this game object has a transform component, a camera component, and an audio listener. So one of the immediate differences is that a game object can actually have multiple scripts attached to it, which will perform different things. And then all of those scripts, which are MonoBehaviours, that are attached to a game object are going to have a reference to the game object itself and the transform component, which is the position, rotation, and scale within our scene. And of course, you can add extra components by clicking on Add Component down here, or create your own new scripts, going to the bottom, hitting New Script, or just typing in the name. So I'll do this GameObject demo and hit enter for create and add. So a second later, we see the component added in here, GameObject demo, and the script is inside of our assets folder. So if we open up this script inside of the editor, then you'll see that the C# script inherits from MonoBehaviour. So if you want a script to be attachable to a game object, it needs to inherit from MonoBehaviour. Whereas a script that you want to create a scriptable object for inherits from ScriptableObject, the class. So I'm going to go to the assets in this project and add a new script here. So I'll call this ScriptableObject demo.cs. So inside of the ScriptableObject demo, I'm going to type in ScriptableObject to automatically fill in the default template for a scriptable object. Now you'll notice a couple things here. Of course, the obvious is that we inherit from ScriptableObject. The other thing is that right above our class name, we have create asset menu as a attribute. And this takes a file name, which is the default name of the scriptable object that we will create in our project, and the menu name, which is where we would find the menu item to create the scriptable object. And of course, we can rename these strings if we want, but I'll just leave it as the defaults for right now. So with that attribute, we add a new menu item. If we right click in our projects folder, we can go up to create scriptable objects, scriptable object demo. Now this creates a scriptable object inside of our asset folder. In our assets folder is where we store scriptable objects while we're editing our game. We don't actually add a scriptable object directly onto our scene hierarchy, though a game object that has a MonoBehaviour script can reference a scriptable object that is inside of our assets folder. So I'll just rename this to test object. And let's create a new game object in our scene. Right click, create empty, and I'll just call this test geo for game object. And I'm going to click on main camera, and I'm going to drag the game object demo script away from here onto the test game object. Now, with a game object, you can create something called a prefab, which also sits inside of your assets folder like a scriptable object does. So to do that, the easiest way would just be to take the game object from your scene and drag it into the project assets. So now what happens is that the object in our scene turns blue, which means that it is now based on a prefab. A prefab is the template for the game objects that exist inside of our scene. You can also click on this arrow in later editions of Unity to jump into the prefab editor, and then you can change any of the settings that you want the prefab template to have, which will by default apply to any game object that is based on that template. So once you have a prefab, you can drag a bunch into this scene or other scenes and just create copies of it. Now you can create copies of an existing scriptable object by instancing it, but by default, when you use a scriptable object inside of your project, if you're referencing something from your assets folder, then that is the scriptable object that's actually going to be used in the game. So a prefab is a template, but by default, the scriptable object is the actual object you're going to be using, which means if you make changes to that object, it's going to store back into the assets folder and update even after the game has stopped. So you have to be careful about that because changing a scriptable object's values can be more permanent in that sense. So let me go ahead and add some settings to the scriptable object in order to demonstrate that key difference. Let's jump into the code here and I'll add some data that our scriptable object will store. So for now, I'll just do a public int count and let's set that to 0. And I'll also jump to the GameObject demo script and add a count here as well. So public int count, and I'll have that start at 0. We can have that start at 0 for both of them. So the field is essentially the same, at least initially. So what we're going to have happen here is that the count is going to increment whenever the update method runs. As you can see, that's once per frame. So count is going to increase quite quickly. But because it's a MonoBehaviour, these values are going to reset when we exit out of play mode. Every time you start your game and you load a scene, all of the game objects are going to reset to whatever their default values are. So let's demo that really quickly. I'll just click on test game object. We can see the field exposed because it's public, so we can see and edit this count field. Let's hit play, and we're going to watch count go up very, very rapidly. But as soon as I exit out of play mode, it goes back to the value of 0. So this is helpful in the sense that every time we load a level, that level is being loaded with the same values, so we expect it to behave the same way each time we run the game. Now let's add in a reference to our scriptable object demo in our MonoBehaviour script. So I am going to want the specific type of scriptable object demo. So I am going to use the class name here, public scriptable object demo, and I'll just call this Scriptable. So now let's go back out to the Unity editor here, and I'm going to drag and drop this test object into the Scriptable field. Okay, so now we have a reference to this, and that reference is still going to be there whenever we hit play. So even though the Scriptable object doesn't exist directly inside of our scene, we can still reference it as an asset in our project. And this also means we can reference it multiple times across different game objects that want a Scriptable object field, or even different objects in different scenes, which can be very helpful. So now to demo how the Scriptable object data persists after we close out the scene, let's take the Scriptable object here, find the count field, and we're going to increment it exactly the same way as our field right here. We're also going to need to make sure that Scriptable is actually set here. Since we have 3 copies of the same game object, we can only increment the Scriptable object if it's actually set as a reference. So if Scriptable is not null, then we will increment the count on it. Okay, so if we click on each of our test game objects, we can see that only the first one has a reference to the Scriptable. All of the counts are set to 0. If we click on the test object, the Scriptable object, I'll actually rename this. I'll just call this Scriptable test. That makes more sense. So if we click on Scriptable test, we can see that the count is set to 0 here. Now, as soon as I hit play, they're both going to start incrementing. So we have each of our game objects incrementing their own fields. And if we click on the Scriptable object, it's also increasing its count. The difference is when it stops, if we click on the Scriptable object, that the value stays there. So this is something you actually have to be careful about, because the Scriptable object is not going to reset every time you turn off play mode. Which means that if the next time you played, you were expecting the value here to be 0, but it wasn't 0, you're going to cause all kinds of problems for yourself. So there are ways you can get around this. One is that rather than using the original Scriptable object, you create an instance of that Scriptable object. So if I set the count here to 0, let's go into the code for the GameObject demo. And let's go create another field, ScriptableObject demo here. And I'll just name it Gameplay Scriptable. So if we just want to take the data stored there and use that as a starting point for the GameObject in our game, then what we can do is just instance it when our script starts. So gameplay scriptable equals scriptable object dot, let's see, instantiate, because we're copying the original object into a new object. So we're copying scriptable, and this is only going to occur if scriptable actually exists. So we want to make sure that we've set it. And then down here, rather than incrementing scriptable, we can increment the gameplay scriptable. So if you want the data to not be stored between sessions, you just create a scriptable object that doesn't actually save into your assets folder and only exists during gameplay. Now, because it's not saved in the assets folder, it wouldn't be as easy to look at it and to know what its values are. So I'll do a debug log on the gameplay scriptable.count here so that we can watch its value increment when the game starts. Okay, so I'll hit play. And there you can see that the value is incrementing there. But if we exit out of play mode and we look at the original scriptable object, we can see that its default values are still set there to the count of 0. However, there's a really huge downside to doing this, which is that if we create the scriptable object after the game loads and it doesn't exist in our assets folder, then we can't just have a predefined reference to this scriptable object across our different game objects. So this gameplay scriptable is something that only exists when the game runs. The scriptable object template exists beforehand, but what if we wanted to have one scriptable object shared between different game objects? There would be other ways that you could have them all hook into the new scriptable game object, for instance, using Unity events, but it's going to lack that option of just being able to drag and drop the original scriptable object to different game objects across multiple scenes and have them all use the same scriptable object by default. So the scriptable field, the original one that just references what's in the project, I can just drag in the scriptable object like this. So now 3 objects that have no idea about the other objects have access to this shared data. And I could create a new scene and still use that same scriptable object. So if I right click, create a new scene, just call it test 2 or something. Let's load into here, actually, instead of creating an object, I'll just drag in the prefab. And then this object in our scene can still use the same scriptable object. So we have 4 objects across 2 scenes that have the same scriptable object dataset. But once again, if our code relies on instantiating the object when the game is running, then we lose that feature of scriptable objects. So that's definitely a major downside. So when it comes to scriptable objects, you may very well want to protect the actual data that is stored in that object and only be able to reference it or get the data, but not be able to set it during gameplay, because you want to make sure that those values stay consistent and cannot be changed. So one thing you could do is to take the field here, make it private. Now we still want it to show up in the inspector so that if we're editing it in the Unity editor, we can set it there, but just not that it can be changed during gameplay. So if we give this field the attribute serialize field, then even though it's a private variable, it's still going to show up in the inspector where we can edit it in the Unity editor, but we can't access it through other scripts because it's a private field. So what we can do is just to create a public int count, and this is going to be a property, and then we have a property on it which is going to get the count field, so we'll return count. So now that we've set our scriptable object up like this, we would need to go back to GameObject demo and change the field reference into the property reference. So we'll get the count, so we can debug log the count, but we can't set the value. It's a read-only property. But honestly, if there is a value that you need to adjust frame by frame like this, such as running a timer, then it probably exists better as a MonoBehaviour, updating the value and then having that reset whenever the game stops. Anyway, I think a scriptable object would be much more useful for things such as game settings. So if there is, say, a starting value for the health of every player, and you want to be able to edit that in the Unity editor, but just everything is going to use that same starting value when the game launches and your characters get created, then that would be a good idea for a scriptable object. As just a data store that you can reference through multiple scripts throughout your game, and none of the scripts need to know anything about each other. They can just simply have a reference to the scriptable object and get the data they need. So in this GameObject demo CS, I'm going to remove the count increment, and we'll still have the debug log. Now let's go out to the editor. I'm going to switch back to the original sample scene. And let's change the count value on the scriptable object to 5. So this is the setting for our game that we want to reference across multiple objects. And now any object that has a reference to it can still debug log and show what is inside of that object or use it in other ways. So let's go ahead and hit play. Then we can see that debug log, what happens here. So we get that value 5 to print out. Really, I only want the debug log to happen once. So let's just take that to the start. Now we'll hit play. And you can see that we got 3 copies of the debug log message for the count value on that scriptable object. So each of our game objects were able to use the data. We're not able to set the data because we didn't provide a public setter function, but that protects the value from being changed accidentally through other classes that shouldn't be messing with it during gameplay. And of course, if we go back to the second scene, test 2, and we hit play on it, we'll still be able to get that debug log to occur here as well. So scriptable objects are a really great way to share data across your game that is going to persist inside of your game project. And then obviously a game object is going to be tied to your scene. You can have multiple scripts attached to those game objects. So one of the other major differences between a MonoBehaviour script and a scriptable object is that MonoBehaviours tie into the Unity lifecycle with many methods you can implement, such as the start function, which triggers once the game object is active in the scene. You also have awake, which comes before start. So awake happens whether or not the script is actually enabled in the scene. As long as it exists inside of the scene, awake happens. But when the script actually starts, that's when start occurs. There are other ones like on enable and on disable, which actually do exist for scriptable objects. But key ones like update and fixed update do not exist for scriptable objects. And that's a really big deal because that means you can't really run things like a timer on the scriptable object. A scriptable object is really going to have no idea about, say, time.delta time, which is so important to many of the game mechanics, such as moving a character around the screen. You have to know how long has occurred, so you know how much to move your character. All of that stuff is stuff you should do in a MonoBehaviour, not in a scriptable object. So scriptable objects, they have no idea about the time in the game. At any time in the game, you can call a method on a scriptable object. So if you want something to occur that a scriptable object should be able to do, for instance, we could just create a public void show count, which could be as something as just debug logging the count like we did in the scriptable object. But we have no update method if we want to call this once per second or on every single frame. So if we wanted a scriptable object to do something like that on a regular occurrence, then we'd actually have to make that happen from within our MonoBehaviours. So for instance, to call this show count, we'd have to do it on our GameObject demo, and we could do, let's see, gameplay scriptable.show count. And so that will definitely work, offsetting all of the time-based work to our game objects inside of the scene with our MonoBehaviour scripts. So one last thing I'll mention for this video is that you can only do coroutines inside of a MonoBehaviour script. So if you want a function that is going to run on the side and it doesn't finish in one go, but the Unity engine keeps going back to it and checking if it's finished, and then you could have a callback when it's done or that kind of thing, then you need to do that inside of a MonoBehaviour script. So if you have, let's say, a public enumerator function, and I'll call it wait for 1 second and then show count. So with these enumerator functions, you can have the function be entered and then Unity will come back to finish it later. So you would do that through something like a yield return new wait for seconds 1, and then let's do gameplay scriptable.show count. So this is something you can only do if you're working in a MonoBehaviour. A scriptable object cannot start a coroutine. So a coroutine, you would start that with start coroutine, a MonoBehaviour method. And let's see, so we want to do the function wait for 1 second and then show count. So just like this. Oh, I guess we need the parentheses. So in Unity, these coroutines aren't truly asynchronous because Unity runs on a single thread. But what will occur is that on that single thread, when it hits our yield return statement, it's going to exit out of this function and come back to it later, and then check if this condition is met. If that condition is met, we'll keep going. If not, then we're going to yield until that condition is met. So basically, it's going to keep coming back here for 1 second and checking if that 1 second is up, and then it's going to show the count after that 1 second occurs. So if you want something to happen that isn't immediate, but you kind of want to trigger it in the future, then this is one way you can do it, and that's only possible in a MonoBehaviour, not a scriptable object. So let's see here. I am going to comment out some of these lines of code. I also only want this coroutine to occur once, so I'm going to move that to the on start. So let's post that up there. So only once per MonoBehaviour script are we going to start that coroutine using the start hook rather than the update on every frame. Okay, so let's go back out, test it, hit play. So initially nothing happens, and then 1 second occurs, and we get our debug log message to pop up here. So that's the correct number of times because this is test2 scene, which only has one test GO object, and that means the script only runs once. So that's pretty much a rundown of the differences between GameObjects and scriptable objects. In a nutshell, if you want something to be temporary, only existing inside of your scene, and then cleans itself up whenever the scene exits or your game stops, then a GameObject is going to be the way to go. And if you want data that is cross-referenceable between different objects and different scenes, it can serve as a settings file in your project where you know it's always going to exist there unless you actually delete it from your project, and that it is going to keep the same values and that any values you change to it are going to persist after you stop playing the game, then a scriptable object is a really useful thing to have there. So that's going to be it for this tutorial. I've been Chris. Thanks for watching to the end, and I will see all of you in my future video content.